Today in the How Do You series, it's how do you solder two rings together. And in this case, we have a semi-mount, obviously, but we're not going to address the stone today. We are addressing putting these two rings together as one. And what makes this particular set a little easier is there's an area cut out and they're made to fit together. But that's not always the case. But the procedures and the process are the same. So we have two separate rings. Our goal is to be able to put them together evenly, solder them down there, and recut that groove so that you're not able to easily detect that anything has ever been done to them. The first step is, because you may not be having them soldered together brand new. Maybe you're having it done 10 years later and they bothered you enough, or maybe you just had a custom band made. So the first thing that needs to be done is they need to be made concentric again. In other words, round, both of them equally, so that they will line up properly. Many rings, over sometimes not very long, become a little oblong side to side, and that is what you can see is exactly the case in this. We use our hammer, that is the rawhide hammer, that doesn't put any dents in the ring, and we give it a few taps so that it rounds it back up without, and you're pushing it down as you go without doing any damage to the shank itself, the shank being the part that goes around the ring. Okay, now I'm trying to make that rock back and forth. It does it. We're going to repeat the process with the other ring. And you can see this equally became a little oblong, left to right, right to left. And again, look at that. That really rocks back and forth. So let's give it a few taps, pulling it down, tapping it down as we go a little bit. We get to a point that we check the size is the same and there's no side to side movement. It is concentric. In order to solder things at the bench and for rings to be able to take that kind of temperature of heat, what will happen if we don't apply the chemicals to it we're getting ready to, will oxidize. It will oxidize. In other words, darken and create a tarnish on it. So this is one of those steps I told you, you'd have no idea what it goes through. And you can appreciate it afterwards because a knowledge of chemicals and their reactions comes with the knowledge of being able to do this. And that takes time from the very beginning as part of a goldsmith's training. So we put it over here in our combination of alcohol and boric acid. And in this case, because we're soldering diamonds, we don't have to worry about the stones getting too hot, because with anything except corundum, ruby and sapphire, and diamond, we would have to take the part that has the stones in it and put it in what we call a heat sink, or use metal clipped on either side to pull the heat away, depending on how much heat sinking we need to do. So if we were doing an opal ring, that baby's going to get submerged in water or these special other chemical materials that absorb the heat before the stone does. But diamonds, they're formed at ultra high temperatures and pressure. They can take any kind of temperature change or the temperature that we're going to reach here at the bench. All right, so let's put these two rings now. We have our chemicals on them. You'll be able to see that. Let's line them up. All right, so I have them lined up the way I want there. Now to clip them even pressure, I take another self-locking tweezer and apply it to the other side. Here we have our solder that we've chosen, and you use a easier solder than what you would in sizing the ring, because if you use the same temperature solder that you did if the ring has been sized, What happens is the temperature of the ring comes up to the temperature of that solder when you're trying to solder the piece together, and it pops the shank. Now, because this is an estate piece and we all tap our rings unbeknownst. I used to have a stick shift car and a ring on my right hand, and I wore off the diagram of the gears that they always usually put on them because I was just tapping with my ring. I don't know, as a nervous little thing when I drove, I just had my hand on the stick shift. It was comfortable, and before I knew it, it was just became something I did. Wore off the stick shift, created all the way around on my ring little worn areas. We don't realize every time we open a doorknob, pressure on the ring. Every time you even open a drawer, there's so many metal drawers. There's so many times that your ring comes in contact with items that can harm it, and you don't even realize it. So that creates what's called work hardening. We all know that if we take a piece of metal and we bend it back and forth long enough, it will break at that point. This is the same type of metallurgy that is going on in the process of when you wear your ring. I've chosen the proper solder and taking the gamble. So we're going to break off a piece of that solder, making sure it's large enough to go the distance between the two rings that I want it to. Because when we solder the rings together, we just don't solder them in just one little tiny 1 millimeter area. We usually like to carry the distance of the weld between the two rings a good 5, 6, 7 millimeters, depending on the size of it. Here's my rings. I want to make sure that the solder flows without it, let's say, binding, because if you use what's called a flux, it will help the solder flow in the joint. So we're going to lightly heat the ring first and then apply the flux. We're going to lightly heat it again. You can see it turn white, so I can tell that the flux is where I want it. Now, these solder picks are made out of real high temperature metals, and so that they can pick up the ball of solder like you just saw me do. All right, now we're going to raise the temperature of the bottom of this ring up to 12 to 1300 degrees, depending on what carat. And if all goes well, that ball of solder will flow in between the two rings. You see temperatures starting to make it melt. And as I bring that temperature up, I can actually push that ball of solder into areas I want it. And solder will go to the areas that are the hottest. There was a ball of solder there. Now what do we have? We have two rings that now have become one. You can see at the bottom that they have been joined by metal, and that's by flowing that solder in between the two pieces. One chemical we put on the ring to prevent oxidation. As you can see, they're still very much yellow and have not darkened, but only a little. But we have chemical on them. It takes one chemical to remove the other. It's actually another acid. So over here, we're going to put our ring in the acid bath and just let it sit there. Depending on how intricate the design of the ring is and how much chemical you think you have, so to speak, heated onto the ring, the flux will flow like a glass. And sometimes it can take an hour to soak it all off. But I don't think this is going to be the case. I have a warm solution, a high concentrate of the proper chemicals, and a steamer. That really helps the process. Okay, I can tell. See the dark area that was on there? It is gone. Now you can see the solder. The solder is the part that is not polished, and you can see that there isn't really a groove between the two rings like there was. What we're doing next is cleaning up the division between those two rings and creating a groove to make it look like nothing was ever done. And to do that, we use our specifically made jeweler's saw with a specifically made very nice fine blade. Our blades are quite expensive and they break very easily. So maybe we'll get through this without breaking one. All right, so let's go to our bench pin and show you how this is done. We have our saw. You can see the solder in between the two, and with this fine blade we have to create an initial groove for it to travel in. You can see there's a polished looking groove between the two, and when we're completely finished it will all blend in together and you'll barely be able to tell that solder was ever added between the two pieces. So just a little more here I see at the end, and we'll be ready for the next step. I'm one that likes to do as much as possible at the bench, leaving the buffer for larger things that require a greater speed and torque, like a silver goblet, let's say. Oh yes, I've polished out silver engravings on different pieces and large pieces, and as many years in the industry as I've been, you pretty much have covered it all, if it's your passion and love like my own. All right, now look at that. You have a pre-polished ring soldered together, lined up evenly, ready for the final finish. We have the inside though that isn't. So we're going to take a brush wheel, and again doing it at the bench, instead of the buffer. So we have a wheel with a smaller enough diameter. Let me get the right compound I want to use. Here we go. This I call yellow glow. It's a it cuts and it polishes, so it's a nice in between grit that will accomplish my goal. Here's the buffer, and always wear eye protection, and I have a very, very well modified dust collector, which helps, of course, not only with keeping dust from breathing it, but also keeps the gold. Oh yes, you wouldn't imagine over time how much gold, if you do a lot of work at the buffer, can be accumulated in the filters. All right, here we go. Let's go with a little bit more speed. Yeah, that's what I want. Now the red rouge, that's the highest finish a jeweler usually uses. All right, we're just about done. Beautiful. Wow, there we have it. It's all ready for either a semi-mount or the center stone to be set right after we clean it. We have our ultrasonic, this is a commercial grade unit. They make little units you can buy, and they're not a true ultrasonic, which is high frequency, but they do shake the water, and any kind of agitation does help clean your rings. So I actually, for the $20, $30, recommend those of you that really have some pieces that you tend to wear enough to get dirty, use the proper solutions recommended, clean your rings. It makes a huge difference in the enjoyment you're going to get from the sparkle and the beauty of the look that they were originally. So, an extra little suggestion, get a little electric toothbrush, a baby's toothbrush or baby electric toothbrush or child's, and basically soft bristles. The agitation gives you enough that you, using a toothbrush yourself, may over agitate scrubbing it. Let the toothbrush do the work. I have quite a few, from everything for cleaning rocks and minerals to doing fine jewelry. They work very, very well. And they're not expensive, of course. So, we have put it in the commercial ultrasonic, which has a heater and all the jazz. Now, for diamond rings, ammonia and water, 50-50 solution. Rubies and sapphires, the same. Anything else by way of gemstones, ammonia, you want to start staying away from. Follow the guidelines. You'll be better off. Better to be safe than sorry. I push it because I know all the properties of gemstones. But for you at home, don't take a chance. You might pull oil out of an emerald. You might, the poor stones totally change the color of them, like turquoise and things like that. All right, let's now go to the steamer for the final cleaning. And with that, ladies and gentlemen, we have accomplished our goal of putting the two rings together in a manner that makes it difficult to tell that we ever added metal and that we ever did anything to the bottom of the rings. They're lined up, ready to go, guaranteed not to turn and get out of place on your hand again. Thanks again for joining me, and I hope that you are coming away more educated than you were. And thanks again for telling your friends and neighbors about this series we're doing so that they can better understand the processes and what goes on behind the bench.